All right, so you're getting really close here. We have new material, no more ice charts. Hooray, hooray. You're going to start off the week with a test, and then you're going to move into balancing half reactions in electrochemical cells, and then you're going to do E cell to G and K. This is all equations in here, so it's just using these. They look complicated at the front end, but once you get used to it, they're not super weird, but they are a little complicated at the front end. But you're just using equations, plugging and chugging. That's what that whole section's about. The half reactions build on the ideas that you actually already covered in Jing Chem 1. I don't know if you remember these ones right here, but this is a reduction. And then this right here, that's an oxidation. And then when you are balancing something like this normally, and this one does balance normally, then you just make sure that you've got the same number on both sides of that. But what happens if you're trying to balance that turning into that? Well, every time you put a 4 on front, then your chlorine becomes unbalanced. So you put a 4, but then your oxygen becomes in a balance, and then it becomes a 16. And I hope you see how crazy that is. So it's kind of a special category. What we do in these weird balancing cases is that we balance them in either acid or base. And they always have a stepwise process of what you add. You start with water, then H+, then electrons, then you balance your electrons, then you combine and cancel. So these are stepwise process to follow to balancing a half reaction. The first few will take a little while, but then once you get good at it, it's like just all the other processes, it'll finally click. And then finally, we're going to be ending that section with electrochemical cells. So those are cool. Those are batteries and all. You'll learn what side's the anode, what side's the cathode. And then you'll also learn a really good equation I didn't actually write down. So E cell is equal to E cathode minus E anode. And you'll look this value on a chart, look up that value on a chart. So it's not a hard number to calculate, but that's what that one is. Then with these equations right here, those are the crazy equations. I'm going to jump over to the G one. So this G equation right here, you actually already learned about it. You learned about it way back up here. Where is it? There it is. It's the third one down. That equation you already learned about. So we're going to use that equation in combination with a new equation. Keep going. There we go. So this is the new equation right here, the lower one. And so you can see since they both equal G, we can set them equal to each other. And basically the idea is that R, T, N, and F, those are all like R is a constant. It's a thermodynamics thing, so it's the 8.314. T is a temperature value. N is how many electrons are moving around the system. F is a constant. E cell you figured out how to calculate last time over here. So you've got practice with that. So these little groupings will help you get between G, K, and E cell. Now, over here, again, previously you learned about E cell right here. This is actually supposed to be E naught because that is what this term is here. And so this only is true as the E cell when it's 1 molar concentrations at 25 Celsius. But if you don't make that 1 molar, which most of the time is not, or if you aren't running it at room temperature, well then it's basically like we have a little correction term that we're adding on. And this is a different version of the same type of correction term. And again, you get that if you divided both sides by NF and NF, you'd have kind of like this E cell equals, and there's that term right there. It's that same term, but it's with Q because it's at not standard concentrations.